Across the dark canvas of the cosmos, galaxies drift like fragile embers carried by an invisible wind. Their light, ancient and exhausted, travels across oceans of silence until it fades into nothingness. Beyond that horizon of fading light, there is no map, no chart, no certain truth, only the suggestion of a frontier and unseen boundary where existence seems to dissolve into mystery. For centuries, humanity has reached outward, convinced that the universe is a totality, that it is everything. Yet the paradox remains: if it is everything, how can there be a beyond? To imagine an edge is to imagine a border against nothingness, a silence more absolute than space, more timeless than eternity itself. Modern science, armed with telescopes and equations, peers into this abyss with unflinching determination. It measures the expansion of galaxies. It listens to the echo of the Big Bang. It models spacetime as a living fabric. And still, behind every discovery, a deeper shadow emerges. The observable universe is not infinite. It is a sphere, a horizon defined not by walls of matter, but by the limits of light itself. Beyond that veil, reality continues, but in what form? No one knows. Perhaps there are other universes, stitched together like islands in an endless sea. Perhaps time itself ceases, leaving only the silent mathematics of eternity. Or perhaps there is nothing at all, and existence is suspended against an unfathomable void. The mystery is not simply in the stars. It is in the very meaning of being, what lies beyond the boundaries of existence. Perhaps the greatest secret of the cosmos is not in what we see, but in what forever escapes our sight, long before telescopes carved windows into the heavens. The question of boundaries haunted human thought. In the silence of ancient temples and the echoes of early philosophies, the first attempts were made to draw a line around existence. The Greeks imagined the cosmos as a perfect sphere, finite yet complete, ordered like a celestial machine. Aristotle taught that beyond the sphere of fixed stars lay nothing at all, not space, not time, not even void. To him, the cosmos was a self-contained whole, bounded by perfection, its edges absolute. Yet even then, shadows of doubt flickered. If nothing lay beyond, how could one even imagine the meaning of outside? Far to the east, Hindu cosmologies spoke of cycles without beginning or end, universes born and dissolved like breaths of Brahman. Here, existence had no true boundary, only rhythms repeating in endless succession. The Vedas described creation not as a line with edges, but as a wheel turning forever. Buddhist thought, too, questioned the solidity of boundaries. Reality, they suggested, was impermanent and dependent, a network of causes without a fixed border. In their meditations, existence was not a sealed sphere, but an endless interplay of becoming and vanishing. Through these divergent visions, a common thread emerged: the recognition that reality might have edges or that it might not. That the human mind struggled to conceive either possibility without contradiction. The paradox was born early, and it has never been resolved. As centuries turned, astronomy and theology entwined. In the medieval imagination, the heavens were ordered into crystalline shells. Earth lay at the center, enclosed by celestial spheres upon which the planets and stars were embedded like jewels. Beyond the outermost sphere lay the Empyrean, the dwelling of the diviner boundary, not of physics, but of faith. This cosmic architecture offered comfort, a structure, a wall, an answer to infinity. Yet it was an answer built not from observation, but from longing. The Copernican revolution shattered this architecture. When the Earth was displaced from the center, the cosmos expanded outward in every direction. The spheres cracked, and the boundaries that had once seemed certain dissolved into air. For the first time, humanity faced a sky without edges. Copernicus's quiet proposal grew into a seismic shift, carried forward by Kepler's ellipses and Galileo's telescope. What had been a finite dome was now a vast, unbounded expanse. Stars no longer affixed to shells, but scattered through immeasurable darkness. The question grew sharper. If the universe stretched outward without end, then where was its edge, or did it have none at all? It was Isaac Newton who gave this new vision its language. His laws of motion and gravitation revealed a cosmos where space extended infinitely in every direction, an endless stage upon which matter moved in obedience to universal law. Time, too, flowed uniformly, indifferent to beginning or end. For many, this was exhilarating, but it also carried a deep unease. An infinite universe introduced paradoxes that gnawed at reason. If space was endless, filled with stars, why was the night sky not ablaze with light in every direction? This conundrum, later known as Olbers' paradox, hinted that something was wrong or incomplete in the idea of infinity. Newton himself wrestled with the implications. An infinite distribution of stars, he admitted, would collapse under its own gravity. To save his model, he imagined a universe perfectly balanced, stars spread so evenly across infinity that collapse was avoided. But the fragility of this idea revealed the difficulty of infinity itself. Boundaries were troubling, but a boundless void was no less disturbing. Existence was either finite and therefore edged, or infinite and therefore incomprehensible. Centuries later, Albert Einstein would transform the question yet again. His theory of general relativity replaced Newton's infinite stage with something more subtle, a fabric of spacetime, curved by matter and energy. Suddenly, the universe could be finite without edges, like the surface of a sphere. One might travel forever without reaching a boundary, yet the total expanse could still be limited. This vision carried a strange elegance, resolving the paradox of edges by dissolving them into geometry. But Einstein himself hesitated. In 1917, he applied his equations to the cosmos and found that they predicted a universe in motion, either expanding or contracting. Unable to accept a universe with a beginning or an end, he introduced the cosmological constant, a mathematical force to hold the cosmos in eternal balance. For Einstein, the idea of a universe that evolved in time was too unsettling, too close to the ancient idea of creation. He preferred a universe without boundaries, not only in space, but in time itself. Yet the sky betrayed him. In 1929, Edwin Hubble revealed that distant galaxies were racing away, their light stretched into red by expansion. The universe was not static, it was expanding. The implications were profound. If it was expanding now, then it must once have been smaller, denser, hotter. In a flash of revelation, existence itself seemed to point back to an origin, a beginning in time. The birth of the Big Bang Theory was the birth of a new boundary. No longer was the universe eternal. It had a history and possibly an edge in time. Georges Lemaitre, the Belgian priest and physicist who first proposed the idea, described it as a primeval atom, an instant when everything was condensed into a singular beginning. To many, this was exhilarating. To others, it was disturbing. The idea that existence itself might have a moment of origin raised the question no science had yet been prepared to face. If it began, what lay before? And if there was a before, what existed beyond the horizon of the beginning? For millennia, humanity had drawn lines around the cosmos, celestial spheres, infinite voids, curved geometry. Each vision offered answers, yet each opened new uncertainties. The ancient Greeks wondered whether beyond the stars lay silence or eternity. The Hindus imagined cycles without end. Newton placed the universe upon an infinite stage, only for Einstein to show that the stage itself was alive, mutable, finite, yet unbounded. And then came the Big Bang, collapsing all certainty into a single haunting truth. Existence itself may not stretch forever backward. It may have emerged. It may have boundaries not only in space, but in time. Thus, the paradox sharpened once more. If the universe began, must it also have an edge? If space and time themselves had a birth, what lies beyond the birth? To speak of before may be meaningless if time itself was created in that instant. To speak of outside may be impossible if space itself is the container of all. Yet still the question endures, unrelenting, waiting at the horizon of thought. What truly exists beyond the boundaries of existence itself? From the very beginning, the human mind has struggled against its own limits, straining to comprehend the vastness it was born into. In Mesopotamia, where the first written myths were etched into clay, the universe was imagined as a dome stretched over a flat earth, surrounded by waters and chaos. Boundaries were firm, visible, protective. The vault of heaven arched above, while below, the underworld formed the counterweight to the sky. Beyond the dome lay primordial waters, infinite but contained, a chaos that only gods could enter. Here, existence was a fragile island, shielded by invisible walls against a greater void. Egyptian cosmology echoed this sense of enclosure. The goddess Nut arched overhead, her body the sky itself, enclosing the world in her embrace. The cosmos was not endless but sheltered, nurtured by deities. To live within boundaries was to live within meaning. To imagine outside was to enter the realm of gods and mysteries, forbidden to mortals. In China, early cosmologies wrestled with similar visions. Some schools imagined the heavens as a round dome resting upon the square earth. Others conceived of a cosmos that expanded endlessly, cycling through phases of growth and decay, an infinite breathing of yin and yang. Even here, the human mind swung between the comfort of boundaries and the terror of infinity. The philosophical schools of Greece brought a new rigor. Plato envisioned the cosmos as a living being, finite yet perfect, with the stars as its eternal organs. Aristotle argued with conviction that beyond the fixed stars lay nothing at all not void. Not darkness, but the absence of any category of being. This nothing was not space waiting to be filled, but an absolute outside, inconceivable and inaccessible. To Aristotle, to ask what lay beyond the universe was to ask a meaningless question. Existence was self-contained, and its outer boundary was the limit of all definition. And yet the evidence mounted. The expansion observed by Hubble, the logical consequences of relativity, the faint traces of a cosmic fireball all pointed toward a universe with a history. The steady-state model, elegant in its promise of eternity, required new matter to appear spontaneously as space expanded, a mechanism that lacked evidence and stretched credibility. Reluctantly, the community began to shift, drawn toward the unsettling conclusion that existence had not always been. The psychological weight of this revelation cannot be overstated. For generations, the eternal cosmos had been a source of comfort. It mirrored humanity's desire for permanence, a stage that endured beyond the rise and fall of civilizations, beyond the brevity of human life. To learn that the cosmos itself was impermanent, that it had a beginning and might someday have an end, was to confront mortality on a scale far greater than the individual. Existence itself was fragile. Reality had an origin, and with this origin came a new, haunting implication. If the universe expands, what does it expand into? The question lingers at the edge of comprehension. In common language, expansion implies growth into space, like air filling a balloon. But relativity insists that the universe is not expanding into anything, it is space itself that stretches, carrying galaxies apart like dots upon the balloon's surface. There is no outside in the conventional sense, no container into which the cosmos grows. And yet, to the human imagination, this explanation feels unsatisfying. If space is all there is, then what lies beyond its edge? If time began in the Big Bang, then what came before? Science cautions that these questions may be meaningless, that beyond and before have no definition when space and time themselves are the fabric of existence. But the mystery remains, pressing against thought like an unseeable wall. Thus, the first scientific reactions to the expanding universe were a mix of wonder and resistance, of exhilaration and dread. Relativity had opened the door to a cosmos alive in time. But with it came consequences that unsettled the foundations of science and philosophy alike. The universe was no longer eternal, and if it had a beginning, then what of its boundary? What lies outside a cosmos born in fire? Even now, nearly a century after Hubble's discovery, the question persists. Scientists model expansion with increasing precision, measure the speed of galaxies, and map the faint glow of the cosmic microwave background. And yet the essential paradox remains unsolved. Existence is finite in age, perhaps finite in extent. But if there are boundaries, what lies beyond them? And if there are none, how can the mind endure the weight of infinity? The first reactions were the beginning of a long reckoning, one that continues into our own age. For in revealing that the universe is dynamic, they forced us to confront the possibility that existence itself is not secure, not eternal, but something far more mysterious, something fragile, bounded, and perhaps always reaching toward a beyond it can never touch. As the reality of cosmic expansion settled into the scientific consciousness, it became increasingly clear that the universe was not merely a backdrop for events, but an active participant in its own story. Galaxies drifted apart, their trajectories dictated by invisible forces we had only begun to understand. The notion that space itself could stretch, carrying matter along with it, was as unsettling as it was beautiful. It suggested a cosmos in motion, a reality that was dynamic, alive, and subject to laws far more subtle than the rigid mechanics Newton had once described. This realization ignited debates across the scientific community. Some physicists embraced the consequences of an evolving universe with awe, marveling at the elegance of a cosmos that could grow, change, and age. Others recoiled, grappling with the existential implications. To accept a universe with a beginning was to confront a profound mystery, one that touched upon the deepest human anxieties. If everything had a birth, then what existed before? If time itself had a genesis, what did it emerge from? Such questions were no longer mere philosophical curiosities. They were unavoidable, inquiries arising naturally from observation and mathematics. Einstein himself, once resistant to the idea of a beginning, found his certainty challenged. He had introduced the cosmological constant to preserve an eternal, unchanging universe, but the evidence was insistent. The cosmos was expanding. Observations of the redshifted light from distant galaxies left no room for doubt. Even the most brilliant minds could not escape the implications. The universe had a past. It had a story. And with that story came boundaries, limits imposed not by walls of matter, but by the very fabric of space and time. The implications were staggering, and not only for physics. Philosophers, theologians, and poets alike found themselves confronted with a reality that could no longer be assumed eternal. For millennia, humans had projected their desire for permanence onto the cosmos, imagining it as a constant, unchanging entity. The night sky had been a reassuring canopy, stars fixed in patterns that outlasted generations. To learn that the universe itself was evolving, that the cosmos had a history, was to face a kind of vertigo. Humanity's sense of place, once anchored in an eternal universe, was suddenly adrift. Resistance to these ideas was natural. Skepticism ran deep, even among the most rational minds. Some feared that the Big Bang Theory was dangerously close to theology, that science was merely cloaking creation myths in technical language. The notion of a beginning was, for many, too unsettling, too suggestive of intent. Yet evidence could not be ignored. Observations of the cosmic microwave background, the faint afterglow of the primordial universe, confirmed that the cosmos had not always been as it is now. The universe had cooled from an initially hot, dense state. The expansion was real. The beginning was real. And then there was the haunting question of the beyond. If the universe is expanding, what is it expanding into? At first glance, this seems simply a balloon inflating into empty air. But relativity reshapes the imagination. Space is not expanding into something external. It is the stage itself stretching, the fabric of existence itself unfolding. There is no outside in the conventional sense, no boundary where one could stand to peer into a larger void. The human mind struggles with this, seeking an anchor in a cosmos that offers none. Every attempt to picture a boundary leads only to paradox. Every model hints at mysteries that elude comprehension. As scientists grappled with these concepts, new possibilities began to emerge. Perhaps the universe has no true edge, only a horizon defined by what we can observe, beyond which light has not yet traveled to reach us. Perhaps what lies beyond is not spatial but conceptual, a domain where the rules of time and matter cease to hold. Some speculated about multiple universes, bubbles of reality forming within a greater metacosmos, each expanding and evolving independently. Others imagined a universe finite in age but boundless in space, curved back upon itself like the surface of a sphere, so that traveling in one direction indefinitely would eventually bring one back to the starting point. These ideas, radical and sometimes unsettling, were attempts to reconcile observation with imagination. The first scientific reactions were not only about data, they were about comprehension, about integrating a reality that defied instinct. Humans are creatures of limits, accustomed to walls, edges, and definitions. The cosmos offered none. Every new discovery stretched the mind further, expanding not just space, but understanding itself. Yet even as theories multiplied, the emotional weight of a finite, evolving universe remained. The realization that existence is not eternal resonates with the same melancholy that art and literature have long explored. The fleeting nature of all things, the fragility of structures once assumed permanent. Stars are born and die, galaxies collide and scatter, and the universe itself is stretching, growing old, moving toward a future we can scarcely imagine. Within this vastness, human lives are ephemeral, yet our curiosity persists. The first scientific reactions, tentative and conflicted as they were, reveal the enduring human drive to confront what lies beyond comprehension, to measure, name, and ultimately wonder at the immensity we inhabit. In this, there is a paradox as profound as any in physics. The universe is expanding, dynamic, and historically finite. Yet the human mind insists on seeking boundaries, edges, explanations. The very act of questioning creates a horizon, a place where knowledge meets the unknowable. And it is at this interface between what can be observed and what cannot that the first reactions of modern science took shape. A mixture of awe, skepticism, and profound unease. The discovery of expansion did not merely alter equations or measurements. It reshaped perception. It forced a re-evaluation of humanity's place in the cosmos, revealing that the universe itself had a story, and that story might extend into regions and times that can never be directly seen. To acknowledge this is to embrace both wonder and vertigo, to stand at the precipice of the known while gazing into a mystery that stretches beyond existence itself. And so, the first scientific reactions to the expanding universe were both exhilarating and disquieting. A recognition that reality was dynamic, that the cosmos had a past, and that questions once thought meaningless before, the beyond, the edge of existence, must now be taken seriously. In the quiet moments that followed, when astronomers and theorists contemplated the redshift of distant galaxies or the faint whispers of primordial radiation, they glimpsed the magnitude of what had been revealed. Humanity had discovered a universe in motion, with a history, and with implications that reached far beyond the confines of observation, toward a horizon that might forever lie just beyond understanding. Long after Hubble had revealed the universe's expansion, the question of its ultimate origin remained unresolved. Observation alone could not speak to the moment of beginning, only to the echoes left behind. It was in this quiet shadow of history, where data met speculation, that the cosmic microwave background would emerge as the first whisper of creation itself. The sky, once assumed eternal and unchanging, bore faint traces of an ancient fire, predicted decades earlier by George Gamow and his collaborators in the 1940s. This afterglow of the primordial universe was a subtle hum permeating all of space. Gamow envisioned a cosmos born in a dense, hot state, a universe where matter and radiation were once intertwined in a searing embrace. As the universe expanded and cooled, he reasoned, a residual glow should remain a faint signature, an imprint of existence's earliest moments. It was a prediction born of imagination, mathematics, and a relentless curiosity about origins. Yet the discovery itself was accidental. In 1965, Arno Penzias and Robert Wilson, while calibrating a radio antenna for mundane communication experiments, stumbled upon a persistent, isotropic noise. At first, it was dismissed as interference pigeons nesting in the horn, urban echoes, or equipment fault. But the anomaly persisted, a faint, unyielding hum from every direction. When cross-checked against theoretical predictions, it became clear they had heard the universe's first light. Photons emitted nearly 14 billion years ago, traveling across expanding space to reach a small instrument perched on Earth. The universe had spoken, and science had finally listened. This discovery confirmed a profound implication. The cosmos had a beginning, a fiery origin, a singular state from which all matter, energy, and space itself had emerged. Yet this revelation also intensified the paradox. If the universe began, then what lies outside that origin? Could one define the boundary of all that exists, or was beyond simply an abstraction, a concept unattainable to both observation and imagination? Scientific minds confronted another challenge, the problem of infinity. For centuries, infinity had been a concept more mathematical than physical, a way to reason about extremes, but never something to measure directly. But now, the expanding universe forced a reckoning. Space itself could stretch without apparent limit, but it emerged from a finite beginning. What does it mean to speak of nothing before creation, if nothing includes no time, no space, no laws of physics? The human intellect falters here, not for lack of skill, but because our cognition is bounded by the very universe it seeks to comprehend. The first speculative boundaries emerged alongside these empirical revelations. Scientists proposed models that sought to reconcile observation with intuition. The steady-state theory, championed by Fred Hoyle and others, offered a cosmos eternal and unchanging, continuously generating matter to maintain density as space expanded. It promised permanence, continuity, an infinite backdrop against which the dance of galaxies unfolded. In contrast, finite origin models embraced the Big Bang, acknowledging the disquieting fact that existence itself was born and that the universe carried within it the scars of its own genesis. Both models offered clarity in different ways, yet both revealed the limitations of certainty. One could describe motion, measure radiation, map galaxies, but the fundamental question remained: if existence has an edge, what kind of edge is it? Human imagination, unbounded by empirical constraint, began to chase these edges. Artists painted cosmic vistas of infinite horizons, of walls of stars dissolving into darkness. Writers conjured entire worlds and universes folding within themselves, infinite yet contained. Scientists, too, allowed speculation to guide inquiry, imagining cosmic membranes, multiverses, and topologies beyond intuition. The edges of existence became a canvas for the mind, a place where observation meets interpretation, and where metaphysics begins to intertwine with physics. In these investigations, the tension between observation and imagination became palpable. The cosmic microwave background, the expansion of galaxies, the birth of light itself all pointed to a universe with a history. Yet each discovery seemed to push the boundary of understanding further away. Where does science end and philosophy begin? When a model predicts what cannot be measured directly, when equations describe spaces and times beyond perception, the line blurs. Knowledge becomes speculation, and speculation becomes wonder. The seed of mystery grew from this soil of evidence and conjecture. If existence has an edge, is it physical, a literal boundary where space and time cease? Or is it mathematical, a limit embedded in the equations that describe reality? Or perhaps it is illusory, a horizon that exists only because consciousness itself cannot grasp infinity. Each hypothesis is fragile, yet necessary. Without them, the mind falters in the void. With them, the imagination stretches alongside the universe, reaching toward a truth that may forever remain just out of reach. As telescopes improved and instruments became more precise, the early investigations deepened rather than resolved the mystery. Radio surveys mapped fluctuations in the cosmic microwave background, revealing anisotropies that hinted at the seeds of galaxies. Observatories probed the depths of space in every wavelength, yet the question of boundaries persisted. The universe was not uniform in every detail, and yet the very concept of an edge seemed unreachable. Each photon measured, each spectrum recorded, was a message from the past, a relic of creation, carrying encoded hints of the universe's structure and evolution. And in these signals, the mind glimpsed the limits of comprehension itself, even in the laboratories and observatories of Earth, where cold instruments hum in precision and calibration. The philosophical undertone of the inquiry is unavoidable. Every measurement of radiation, every calculation of expansion, evokes the deeper question: Does the universe have an exterior? Is there a beyond in which the cosmos sits, or is space and time all-encompassing, stretching without context? The answers remain speculative, yet the pursuit illuminates the human condition. It is a reminder that knowledge is not merely accumulation of facts, but a dialogue with the unknown, a slow meditation on existence and its possible limits. And so, the early investigations planted a profound awareness that the universe is both observable and mysterious, measurable and ineffable. The cosmic microwave background speaks of beginnings. The stretching of galaxies testifies to growth. The very mathematics of space and time gestures toward boundaries we may never touch. Scientists, artists, philosophers become witnesses to a reality that is simultaneously intimate and terrifying in its scope. The edge of existence may lie hidden in the folds of space-time, in the geometry of expansion, or in the limits of perception itself. Whatever its nature, it provokes the same awe and uncertainty that has accompanied every attempt to define what lies beyond the known. In these early investigations, the dialogue between observation and imagination forged the foundation for all future inquiry. The universe revealed its birth, yet refused to reveal its beyond. Humanity, in turn, has been compelled to reach further, think deeper, and dream wider. Every measurement, every theory is a step toward a horizon that may exist only as a concept, a place where science brushes against the infinite and philosophy whispers of the edges of reality. The mystery endures. The universe, born in fire, expanding in silence, carries within it traces of a beginning and the suggestion of boundaries. Yet the human mind, ever seeking, continues to trace its contours, to push against the limits of understanding, and to ask the same haunting question that first drove philosophers and scientists alike. If existence has an edge, is it something we can ever perceive, or is it destined to remain a horizon beyond the reach of thought? The human gaze, once confined to the naked stars scattered across the night sky, began to pierce deeper, to listen to the universe in wavelengths invisible, to measure light that had traveled across time itself. The early investigations, which had unveiled the existence of cosmic microwave background radiation, were merely the first whispers. They hinted at a universe with a past, yet the full narrative remained obscured, concealed within subtle fluctuations, tiny ripples frozen into the fabric of space. It was the COBE satellite, launched in 1989, that first transformed these whispers into a map. COBE revealed that the microwave background was not uniform, but contained delicate anisotropies, regions slightly hotter or colder than their surroundings. These were the fingerprints of the universe's infancy, traces of density variations that would eventually seed galaxies, clusters, and cosmic structures. The observations were at once precise and poetic, the afterglow of creation painted across the sky, a frozen memory of a time when the cosmos was mere fractions of a second old. In every pixel of this map, one could see the subtle dance of matter and energy, the delicate push and pull that would shape all of existence. The story deepened with WMAP, the Wilkinson Microwave Anisotropy Probe, launched in 2001 with greater sensitivity and resolution. WMAP unveiled the universe with unprecedented clarity. It confirmed the Big Bang's predictions, measured the universe's age with exquisite precision, and revealed a cosmos dominated by components invisible to the eye, dark matter and dark energy. These discoveries transformed our understanding of boundaries. The observable universe, once imagined as vast but finite, became defined not by an edge in space, but by the horizon of what light had reached us since the beginning of time. It was a scientific boundary, a horizon dictated not by walls, but by the finite speed of light and the universe's finite age. Beyond this horizon, the cosmos may continue, unreachable, unknowable, a reminder of the limits imposed not by matter, but by the nature of observation itself. Planck, launched in 2009, took this exploration further still, mapping the cosmic microwave background with astounding precision. It revealed the subtle geometry of space, hints of cosmic inflation, and the delicate harmonies of the primordial universe. Inflation, the rapid expansion of space in a fraction of a second after the Big Bang, was a revelation. In that infinitesimal instant, all of existence was stretched and smoothed, a process that would determine the large-scale structure of galaxies, the distribution of matter, and the very shape of reality itself. Inflation suggested that the cosmos, though bounded in age, might be boundless in extent, that the edges of existence could be hidden beyond a veil of space-time inflated beyond our capacity to observe. Yet even as these missions illuminated the universe's earliest light, they revealed new mysteries. Dark energy, a force unknown and invisible, was accelerating the expansion of the cosmos. Galaxies drifted apart faster with each passing eon, the very fabric of space stretching outward, carrying the boundaries of existence with it. The observable universe, our horizon of knowledge, receded as space itself expanded, suggesting that some regions would forever lie beyond the reach of any telescope or probe. Dark energy was a reminder that existence is dynamic, and that boundaries are not static markers but shifting, evolving limits that challenge our perception. In parallel, dark matter emerged as another enigma. Though invisible to telescopes, its gravitational influence sculpted the cosmic web. Galaxies swirled, clusters formed, and the universe assumed a structure dictated by something unseen, a scaffolding underlying the luminous cosmos. It was a boundary of perception. What we see is only a fraction of reality, constrained by the light that reaches us, while unseen forces guide the evolution of everything we can measure. Here, science encounters a profound limit, where observation is indirect, and knowledge is mediated by inference and mathematics. Black holes added a further layer of paradox. Regions of space-time where gravity is so intense that not even light can escape. They are boundaries where the known laws of physics collapse. The event horizon marks the edge of observable phenomena. Beyond it, reality becomes unknowable, compressed into singularities where time and space lose meaning. Black holes serve as cosmic mirrors for the universe itself. They remind us that even within a universe we can measure, there exist edges, horizons, and limits that defy comprehension. If light cannot escape, if time ceases to behave as expected, then our instruments, our mathematics, and our imagination are all confronted with the ultimate boundary. Observation itself, in this era, became a boundary. Telescopes, satellites, and detectors reached the farthest edges of what light could convey. Mathematical models stretched to describe inflation, dark energy, and the cosmic web. Yet every equation, every image, only hints at deeper layers. Science can map the visible, calculate trajectories, and predict behavior, but the universe retains a veil, a horizon of uncertainty. Beyond lies speculation, realms where space and time may extend indefinitely, regions causally disconnected from our own, or perhaps the very limits of what can exist. Within these breakthrough observations lies a subtle philosophical weight. Each discovery enlarges the scope of knowledge while simultaneously highlighting limits. The universe, once assumed eternal and immutable, is now revealed as dynamic, finite in age, yet possibly infinite in scope. The boundaries of existence are not walls, but horizons defined by light, gravity, and the very laws that shape spacetime. Science can describe the contours of the observable, measure expansion, and detect the influence of unseen forces, but it cannot pierce every veil. The unknown persists, a horizon that recedes as understanding grows, demanding imagination, reflection, and humility. The cosmic microwave background, the fingerprints of inflation, the invisible scaffolding of dark matter, the accelerating expansion driven by dark energy, and the event horizons of black holes all speak to the same truth. Existence is layered, structured, and bounded, yet in ways that are not immediately apparent. Boundaries may be defined by physics, by observation, by the reach of light, or by the nature of spacetime itself. Each breakthrough observation has illuminated a fragment of this reality, but the universe retains its ultimate secrecy. A profound reminder that to understand the cosmos is to confront the edge of comprehension. These missions also underscore the unity of inquiry. Observation, mathematics, theory, and imagination converge to explore questions that have no simple answers. The early light of the universe, stretched and smoothed by inflation, becomes a bridge to understanding its expansion, the formation of galaxies, and the invisible scaffolding that structures reality. Yet every answer reveals more questions. If dark energy drives eternal expansion, does the universe have a final state? If the observable universe is only a fraction of all that exists, what lies beyond the horizon? If black holes conceal singularities, what is the nature of space where physics fails? In this way, breakthrough observations are both revelation and reminder. They reveal the universe's history, structure, and dynamics, but they also remind humanity of the vast unknown. Science illuminates the cosmos, yet its tools are bounded. Telescopes cannot see beyond light's reach. Equations cannot describe what lies outside spacetime, and even imagination struggles with infinity. The boundaries discovered are simultaneously physical, mathematical, and perceptual, a triad that frames existence without fully defining it. And so, as Cobe, WMAP, and Planck charted the faint light of creation, humanity began to recognize the scale of what remains unseen. The universe is born in fire, stretched by inflation, structured by invisible forces, and accelerating outward into a horizon we may never touch. Each observation is a step toward understanding, yet each reveals the persistence of mystery. The cosmos invites reflection as much as measurement, contemplation as much as calculation, a reminder that the boundary of existence may not be a wall to reach, but a horizon to approach, ever receding, ever profound, in this continuum of discovery. Breakthrough observations are milestones, marking humanity's journey toward the limits of comprehension. They illuminate a universe both intimate and immense, finite in history yet possibly infinite in expanse. They reveal the intricate interplay of matter, energy, space, and time, while hinting at regions beyond perception where the rules we know may dissolve. And above all, they confront the most haunting question: if existence has a boundary, what lies beyond it, and can any observer, in principle or imagination, ever know? As the precision of cosmic observation increased, the universe revealed subtleties previously unimaginable, tiny fluctuations in the cosmic microwave background, imperceptible to the human eye, contained encoded patterns from the earliest moments of existence. These ripples were the fingerprints of inflation, the fleeting epoch in which space itself expanded faster than light could travel, smoothing irregularities and imprinting subtle curvature across the cosmos. In that brief instant, the blueprint for every galaxy, every cluster, every filament of the cosmic web was laid down, a silent and invisible architecture spanning the horizon. It was as if existence itself had whispered the rules of its unfolding into the fabric of spacetime, leaving behind a record readable only by instruments of extraordinary sensitivity. Each new measurement revealed more than just the structure of the cosmos. It revealed the limitations of perception. The universe, in its infancy, had been a seething, hot plasma, opaque to light. It was only after 380,000 years that photons decoupled from matter, traveling freely across space to form the cosmic microwave background we observe today. This means that even with the most powerful telescopes, the universe as it existed prior to that era remains hidden from direct view, accessible only through theoretical extrapolation. The boundary of the observable universe is thus defined not by walls or edges, but by the opacity of the primordial plasma horizon beyond which we may never directly witness events. A reminder that some boundaries are intrinsic to the nature of reality itself. The discoveries of dark matter and dark energy further complicated this picture. Dark matter, though invisible, exerts a gravitational influence shaping galaxies, clusters, and cosmic voids. It forms an unseen skeleton that supports the luminous cosmos, guiding matter along trajectories that our instruments can only infer. Dark energy, by contrast, drives accelerated expansion, stretching space itself and pushing the cosmic horizon ever outward. These phenomena introduce boundaries of a different sort, limits not of space, but of detectability. They define what can be observed, what can influence matter, and what can be predicted. In a universe dominated by invisible forces, existence itself seems to be partially concealed, as if reality has deliberately hidden its most fundamental scaffolding. Black holes add another layer of profound boundary. Within their event horizons, the familiar laws of physics collapse. Matter and energy are compressed to extremes where time dilates and space curves infinitely. These are not merely objects in the cosmos. They are manifestations of limits, points where understanding and measurement fail. The existence of singularities suggests that even within our universe, there are regions where knowledge cannot penetrate, where conventional definitions of space and time break down. Black holes thus serve as microcosms of the larger mystery. They are boundaries within boundaries, edges of comprehension embedded in a cosmos that itself may have an ultimate horizon. The concept of the observable universe, combined with inflation, dark matter, and dark energy, frames a profound paradox. Observational limits are dictated by the speed of light and the universe's finite age. Yet space may extend infinitely beyond what we can perceive. Regions beyond our horizon may have formed independently, evolving under the same laws, or perhaps entirely different ones. The very idea challenges intuition. Our most precise maps and instruments reveal only a fraction of what exists, and yet even this fraction is vast beyond comprehension, containing hundreds of billions of galaxies, each with billions of stars. The horizon becomes a philosophical as well as scientific boundary, a place where mathematics, observation, and speculation converge. Breakthrough observations also illuminate the dynamic interplay between measurement and theory. Missions like COBE, WMAP, and Planck do more than record data. They test the predictions of cosmology, confirming some while raising new questions. Fluctuations in the cosmic microwave background match the statistical fingerprints of inflation, yet the precise mechanism remains unknown. Dark energy's nature is inferred from the acceleration of expansion, but its origin is mysterious. The universe, in revealing more, paradoxically conceals more, creating a cycle where every answer deepens the horizon of ignorance. Science here is not a march to certainty, but a dialogue with the universe, a careful negotiation at the edge of comprehension. The emotional and philosophical weight of these observations cannot be overstated. To look upon maps of the cosmic microwave background is to confront the memory of creation itself. To measure the acceleration of galaxies is to witness the universe stretching beyond reach, carrying future light away from us, making distant regions forever inaccessible. To consider dark matter and black holes is to recognize that what is most real may also be most invisible, that the universe's architecture is partly hidden from the instruments that define modern science. In each of these phenomena, existence is revealed and obscured simultaneously, boundaries emerging as both discovery and limit. Observation itself becomes a meditation on the nature of knowledge. The edge of what can be known is determined not only by instrumentation, but by the structure of reality. Telescopes, satellites, detectors, and mathematical models extend our perception, yet they also delineate the horizon. Beyond lies the unknowable, the regions of space and time where photons have not yet arrived, where singularities collapse the laws of physics, where invisible forces dominate. These are boundaries not of matter but of comprehension, thresholds where even the most sophisticated science must pause. An imagination must take over. Within this interplay of observation and speculation lies the subtle beauty of breakthrough discoveries. The universe speaks in photons and curvature, in ripples of radiation, in the dance of galaxies, in invisible forces, and in the silence beyond horizons. Each observation expands our understanding while simultaneously reminding us of limits, of edges that cannot be crossed, of questions that cannot yet be answered. The cosmos becomes a mirror, reflecting both what exists and what lies beyond our perception, revealing the profound connection between the observed and the unknown. These insights also underscore the continuity of human inquiry, from the first telescopes to sophisticated satellites, from theoretical models to precise measurements. Each step has been both a technical achievement and a philosophical exploration. Humanity's quest to chart the universe's early light, to detect its structure, and to infer its evolution is also a journey toward understanding the nature of existence itself. In confronting boundaries of light, of space, of time, of physics, we confront the limits of knowledge, the edges of perception, and the mystery that lies beyond even the most meticulous observation. The breakthroughs of WMAP, and Planck are thus milestones not only in astrophysics but in the human contemplation of reality. They reveal a universe born in fire, smoothed and stretched by inflation, structured by unseen forces, expanding ever outward under the influence of dark energy, and punctuated by regions where physical laws collapse. These discoveries illuminate a cosmos, both comprehensible and inscrutable, a universe with horizons, limits, and boundaries, yet with mysteries extending beyond all observation. Ultimately, breakthrough observations teach that boundaries are not only physical, mathematical, or observational, they are conceptual. They are where science meets philosophy, where measurement encounters the imagination, where understanding brushes against infinity. In revealing the early light of the universe, its expansion, its invisible scaffolding, and its accelerating growth, Science has delineated the edge of the observable and hinted at what may lie beyond. Yet the ultimate nature of existence, the final frontier, remains elusive, a horizon at once tangible and unreachable, inviting wonder, contemplation, and the relentless pursuit of understanding. The universe, in all its complexity, continues to challenge and inspire. Breakthrough observations illuminate the architecture of reality while simultaneously revealing the profound limitations of perception. In mapping the early light, measuring the forces that shape existence, and charting the behavior of matter and energy across cosmic scales, humanity approaches the edge of knowledge, peering toward a beyond that may forever lie just out of reach. And in this pursuit, we glimpse the sublime, a universe that is at once knowable and mysterious, boundless and finite, observed and unobserved, an eternal invitation to wonder. The universe, vast and luminous, conceals a paradox at every scale. Galaxies drift in clusters, cosmic filaments stretch across hundreds of millions of light years, and yet the universe is astonishingly uniform. Observations of the cosmic microwave background reveal a temperature so consistent across the sky that it strains understanding. How can regions so distant, so seemingly disconnected, share the same properties? This is the horizon problem, a question that pierces the heart of cosmology and hints at hidden mechanisms stretching beyond perception. If light could not travel between these regions in the infancy of the universe, then why do they appear as one coherent entity? The answer seems to lie not in the familiar realms of matter and energy, but in processes beyond direct observation. Whispers from the first fractions of a second when space itself expanded faster than light, smoothing irregularities and sewing together a uniform cosmos. Even deeper lies the flatness problem. Space, on cosmic scales, appears remarkably balanced, finely tuned in its curvature to a degree that borders on implausible. The universe is neither collapsing under its own gravity nor stretching so rapidly as to tear itself apart. It exists in a delicate equilibrium, a geometric perfection that demands explanation. Why should the cosmos hover so precisely at this threshold? Cosmologists suggest that inflation, the brief epoch of exponential expansion, may have stretched space so thoroughly that curvature became nearly imperceptible, leaving behind a universe that appears flat, stable, and improbable. Yet the mystery persists. This precision hints at unseen principles, constraints, or perhaps deeper realities that guide existence itself. Speculation naturally arises in the face of such puzzles. The multiverse hypothesis emerges from these anomalies, proposing a staggering vision. Our universe may be but one of countless others, each born with its own laws, constants, and histories. Beyond our observable horizon could lie realms utterly different, where matter behaves differently, forces have altered magnitudes, and space itself may be shaped in ways unfathomable. In this scenario, the edge of existence is not a boundary in the traditional sense, but a vast landscape of unobservable realities, each a universe in its own right, collectively forming an expanse beyond imagination. Within such a vision, our cosmos is a single bubble, delicate and rare, floating in an infinite ocean of possibilities. Even more radical is the holographic principle, a notion that reality as experienced may be a projection from a deeper, more fundamental boundary. According to this idea, all the information contained in a volume of space could be encoded on its surface, suggesting that what we perceive as three-dimensional space is, at its core, a shadow of processes occurring on an unseen horizon. This transforms the concept of boundaries. Existence itself could be emergent, a projection from laws and interactions at a scale beyond direct perception. In such a framework, the universe is simultaneously real and illusory, tangible and encoded, stretching the human mind to reconcile observation with abstraction. Beneath all visible phenomena lies the quantum vacuum, a seething sea of fluctuations that underpins every particle and force. Quantum fields, pervasive and invisible, hint at layers of reality that defy classical intuition. Empty space is far from empty. It hums with potential, with virtual particles flickering in and out of existence, with forces that shape the evolution of galaxies and dictate the behavior of matter at the smallest scales. Here, boundaries blur. The vacuum is a medium through which the cosmos manifests, a substrate that is real yet intangible, where the line between existence and non-existence becomes porous and uncertain. Even the very fabric of spacetime is not smooth but foamy at the Planck scale. Quantum mechanics predicts that at scales billions of times smaller than a proton, space and time fluctuate violently, a chaotic microstructure where geometry itself loses meaning. This space-time foam suggests that boundaries may not be continuous surfaces, but discontinuous, fluctuating, and probabilistic. The universe's apparent smoothness is an emergent property, a macroscopic illusion built upon a foundation of turbulence and uncertainty. At these scales, the notion of a clear beyond dissolves. Reality becomes a seething, probabilistic network, where classical intuition fails and the familiar rules of existence fragment into waves, probabilities, and singularities. Within these layers, a terrifying possibility emerges, beyond the cosmos, beyond observable universes, beyond the holographic projection, beyond quantum fields and space-time foam. There may be absolute nothingness, a state not merely empty, but devoid of potential, a true absence of space, time, matter, and even laws. To contemplate such nothingness is to confront a void so radical that it challenges both reason and imagination. It is a horizon beyond the horizon, where the language of physics falters and only philosophical meditation remains. If boundaries of existence terminate here, they do so in a silence that is absolute, a cessation that may forever elude observation or comprehension. Yet even within this contemplation, there is beauty. The universe's mysteries reveal the extraordinary depth of reality, layers upon layers that interweave observation, theory, and imagination. The uniformity of the cosmos, its delicate flatness, the possibility of multiple universes, the holographic encoding of reality, the seething quantum vacuum, and the chaotic space-time foam all converge to suggest a cosmos far more complex, subtle, and profound than everyday perception can capture. Each discovery, each hypothesis, illuminates a fragment of the whole, while simultaneously hinting at horizons that recede with understanding. Science, in grappling with these questions, approaches the boundary of human knowledge itself. Instruments, satellites, and observatories extend reach and perception, while mathematics formalizes the rules underlying phenomena. Yet every step toward clarity exposes new limitations. Regions of space remain beyond light's reach. Scales of quantum gravity remain inaccessible to direct measurement, and the ultimate nature of existence and nothingness remains speculative. In this tension, curiosity persists, driving inquiry, imagination, and philosophical reflection. The pursuit is not only of facts, but of understanding, of situating humanity within a cosmos whose boundaries are as enigmatic as they are vast. And so, the mystery deepens. The universe, expanding and uniform, finely tuned and structured, presents boundaries both observed and theoretical, while hinting at realms entirely beyond perception. Cosmic inflation, the multiverse, quantum fields, spacetime foam, and the possibility of absolute nothingness collectively suggest that the beyond is not a simple edge, but a complex, layered frontier. To explore it requires more than instruments or equations. It demands reflection, intuition, and the courage to confront ideas that strain both reason and imagination. In this unfolding narrative, the observer becomes part of the story. To measure, to speculate, to imagine is to participate in the cosmos itself, tracing its structures, mapping its evolution, and contemplating its limits. Each breakthrough, each anomaly, each theoretical insight becomes a brushstroke on the canvas of understanding, painting a universe that is simultaneously knowable and mysterious, bounded and infinite, tangible and abstract. The boundaries discovered in these explorations are both literal and metaphorical, marking the limits of light, matter, observation, and comprehension, while inviting speculation about what lies beyond. Ultimately, the universe teaches humility. Its uniformity, its finely balanced geometry, its invisible forces, its quantum turbulence, and the potential void beyond remind us that knowledge is provisional, perception is limited, and existence may be richer, stranger, and more profound than any single human mind can fully grasp. The mystery deepens because reality itself is layered, multi-scale, and entwined with the unknown. Boundaries are not merely spatial but conceptual, where science meets philosophy and observation meets imagination. Here, at this edge, the universe extends an invitation to explore, to reflect, and to wonder at the profound enigma of what truly lies beyond existence. At the smallest conceivable scales, reality begins to fray, revealing edges that defy intuition. The Planck length, a mere 10,3,510, 35 meters, marks a threshold beyond which classical notions of space cease to exist. At this scale, distances are no longer smooth and continuous, but grainy and probabilistic. The very concept of location falters, and geometry itself becomes uncertain. To imagine this boundary is to confront a universe so different from our daily experience that the mind struggles to reconcile perception with possibility. Here, the extreme edge of science becomes not only a limit of measurement, but a philosophical threshold, a place where existence itself seems to whisper its hidden rules, teasing the boundaries of understanding. Even larger yet, no less enigmatic are singularities. Within black holes, matter collapses to points where density and curvature diverge toward infinity. Time dilates infinitely, space curves beyond recognition, and the familiar laws of physics crumble. Singularities are more than cosmic oddities. They are the starkest manifestation of the limits of human knowledge. They are boundaries where comprehension fails, where equations predict infinity but provide no tangible answer. To peer into a singularity is to confront the failure of conventional reality, a place where the familiar scaffolding of matter, energy, and space-time dissolves into the unknown. The existence of such points suggests that boundaries are not merely physical, but conceptual, arising wherever our models of reality reach their breaking point. Efforts to understand these extremes have led to the quest for quantum gravity, an attempt to unite the elegant continuum of Einstein's relativity with the probabilistic world of quantum mechanics. Approaches like string theory and loop quantum gravity propose that space and time themselves emerge from more fundamental entities vibrating strings, quantized loops, or networks of discrete relationships. In these frameworks, boundaries are not lines or edges in the traditional sense, but thresholds where emergent phenomena begin to manifest. The universe at its most extreme may be a lattice of interactions, a sea of potentiality from which space-time, matter, and energy emerge as macroscopic approximations of deeper principles. Here, science and philosophy converge, as conceptual limits define the very notion of what it means to exist. The challenge of defining outside becomes acute in this context. If space-time itself is all there is, then what does it mean to speak of beyond? Outside presumes a frame of reference, a surrounding space. But when space and time are themselves emergent, the concept loses coherence. Cosmologists confront the unsettling possibility that there is no external vantage point, no container within which the universe is embedded. Boundaries, then, are not literal walls, but horizons of comprehension, limits imposed by the structure of reality itself, rather than any enclosing surface. To ask what lies outside the universe may be analogous to asking what lies north of the North Pole, a question that breaks the usual rules of logic, yet invites profound reflection. Hypothetical constructs like wormholes offer tantalizing glimpses of beyond, mathematically permitted by Einstein's field equations. These bridges of space-time suggest tunnels that connect distant regions, potentially linking one universe to another or one point in space to another instant in time. Yet one remains speculative. No empirical evidence exists, and their stability requires exotic forms of matter that may or may not exist. Still, as conceptual tools, they illuminate the extreme edge of science. They challenge assumptions about connectivity, boundaries, and the nature of space, revealing that what we perceive as insurmountable distances may in principle be traversable in ways our intuition cannot yet grasp. Wormholes, whether real or purely mathematical, underscore the profound interplay between physics and imagination at the frontier of understanding. Even as instruments push the observable universe outward, we must distinguish between the edge of observation and the true boundary of existence. Telescopes map billions of galaxies, yet the cosmic horizon limits what light has reached us since the Big Bang. Beyond this horizon may lie vast expanses we cannot detect, regions whose light will never intersect ours, universes forever hidden. The boundary of observation is a human construct, imposed by the finite speed of light and the finite age of the cosmos. The universe itself may have no edges, no ultimate perimeter, only horizons of perception that expand as knowledge advances. This distinction reframes the idea of a boundary. Existence may extend infinitely, yet our understanding of it remains necessarily limited, a horizon defined not by matter, but by cognition. At this extreme edge, the line between physical and conceptual boundaries blurs. The universe is bounded not solely by matter, energy, or space, but by the limits of knowledge, perception, and imagination. Singularities, Planck scales, quantum foam, and hypothetical wormholes are thresholds that test the coherence of theory and the capacity of understanding. Boundaries exist where conventional tools, observation, and logic reach their limits, and where reflection, speculation, and philosophical inquiry become necessary companions to science. The edge of existence is as much a conceptual frontier as a physical one, a terrain where the known and the unknown intertwine, and where the mind must navigate probabilities, paradoxes, and uncertainties. Even in confronting these extremes, there is a continuity with earlier discovery. The Planck scale is linked to the cosmic microwave background, to inflation, to dark energy, and to the formation of large-scale structure. Singularities connect to the black holes and the edge of observable galaxies. Wormholes echo the multiverse and the horizons considered in quantum cosmology. Each extreme reveals patterns consistent with broader laws, while simultaneously hinting at domains beyond direct measurement. Boundaries are recursive. The small reflects the large, and the conceptual mirrors the physical. The universe, at every scale, offers glimpses of both coherence and mystery. A structure layered with horizons, edges, and unobservable realms. Philosophically, this realization carries profound implications. Boundaries are not absolute. They are emergent, relational, and contingent on perspective. To confront the extreme edge of science is to recognize that what we call reality may be only one manifestation of deeper principles, and that existence itself may be bounded by logic, probability, and perception as much as by matter or space. The edges of black holes, the foam of quantum spacetime, and the Planck scale are not merely scientific curiosities. They are signposts pointing toward the nature of reality, markers indicating that comprehension has limits, yet that inquiry can continue endlessly, along horizons yet unimagined. At the same time, this edge evokes wonder. To probe the smallest scales, the densest singularities, and the most remote horizons is to participate in the unfolding narrative of existence. The universe is both vast and intimate, extending from the depths of quantum foam to the edge of observable galaxies, from the deterministic curvature of spacetime to the probabilistic landscape of hypothetical multiverses. The extreme edge of science is where curiosity meets limitation, where imagination and reason converge, and where the human mind, even in its frailty, reaches toward the infinite. Here, at the confluence of measurement, mathematics, and philosophy, the universe asserts its dual nature. It is knowable and unknowable, structured and chaotic, bounded and boundless. Boundaries exist, yet they are not walls, they are horizons, thresholds, and conceptual frameworks that define understanding while simultaneously pointing beyond. Planck length, singularities, quantum gravity, wormholes, and observational limits are all part of a continuum that spans the small, the large, the observable, and the speculative. Each discovery illuminates a fragment of reality, while exposing the limits of comprehension, reminding humanity that the edge of science is also the edge of imagination. Ultimately, the extreme edge of science teaches humility and awe. Boundaries, once thought to be physical demarcations, are revealed to be relational, probabilistic, and conceptual. The universe may have no true outside, yet it possesses horizons, limits, and thresholds that define experience and knowledge. To explore these frontiers is to engage with existence itself, to confront uncertainty with curiosity, and to navigate the delicate interplay between observation, theory, and speculation. In this pursuit, the human spirit traces the outlines of reality, feeling both the weight of incomprehension and the exhilaration of discovery. And so, science at its extreme edge is not merely a catalogue of phenomena, it is an odyssey of understanding. It stretches from the Planck length to black hole singularities, from the theoretical bridges of wormholes to the limits of observable light, from the quantized vacuum of space-time to the probabilistic emergence of reality itself. In this journey, boundaries are not fixed points, but evolving frontiers, shaping perception, thought, and inquiry. They are conceptual as much as physical, inviting reflection, speculation, and wonder. Here, at the edge, existence is revealed in its most profound duality, a cosmos simultaneously knowable and unknowable, bordered and boundless, tangible and abstract, a mystery that compels the mind to look, to measure, and to imagine what lies beyond. The universe, in the eyes of contemporary cosmology, is a theater of extremes, where time, space, and matter dance along the contours of profound possibility. One of the most compelling frameworks arises from the theory of eternal inflation. In this vision, the cosmos is not a singular entity, but a vast, proliferating expanse where universes bud endlessly, each forming its own pocket of reality. Inflationary fields, initially uniform, decay in localized patches, generating bubble universes that expand independently, like seeds carried on an unseen cosmic wind. Boundaries in this landscape are ephemeral. The birth of one universe does not mark an edge, but a new beginning. Each pocket universe may possess different physical constants, alternative forms of matter, and distinct geometries of spacetime. In contemplating eternal inflation, humanity confronts the cosmos without a final boundary, a tapestry of existence stretching indefinitely, woven from processes that defy finite description. Cyclic cosmology presents another, equally captivating perspective. Here, existence is not linear but rhythmic, a cosmic pulse of death and rebirth. Universes expand, age, and then collapse, only to emerge anew in a succession of cycles that could extend infinitely into the past and future. In such a model, boundaries are temporal rather than spatial. The end of one epoch is the seed of another, a renewal emerging from dissolution. The Big Bang itself becomes one of many, an episode in an eternal cadence. This cyclic vision invites reflection on the nature of time, causality, and continuity. The universe may never truly vanish. It only transforms, shifting from one configuration to another, each cycle containing echoes of what came before and foreshadowing what is to come. Even the notion of an ultimate beyond dissolves, replaced by an infinite temporal horizon, an unbroken continuum of creation and collapse. String theory further expands the imagination, proposing that reality is constructed from one-dimensional strings vibrating in dimensions far beyond perception. These dimensions, compactified and curled upon themselves, form the hidden scaffolding of existence. Each mode of vibration corresponds to a particle, each resonance a fundamental force. The boundaries of existence, in this framework, are not merely spatial or temporal, they are dimensional. Beyond the three dimensions we perceive, additional axes may extend into realms inaccessible to observation, shaping the laws of physics in ways both subtle and profound. Boundaries are thus deeply embedded within the architecture of reality itself, concealed yet influential, determining the behavior of matter, energy, and even the expansion of space-time. The multiverse, a natural consequence of eternal inflation and string theory, challenges the very notion of a cosmic horizon. Our observable universe may be but a single bubble in a vast froth of universes, each disconnected from the next, each evolving according to its own parameters. Beyond the limits of light and causality lies a landscape of realities, an infinite ensemble in which the familiar laws of physics may hold or may be radically altered. Boundaries in this multiverse are not walls, but separations defined by causality and the reach of interaction. Humanity's observational reach encounters only a fraction of this vastness. Yet even the contemplation of these distant, unseen domains stretches imagination, demanding reflection on the scale and diversity of existence. In considering the universe's future, theorists confront scenarios that emphasize the fragility and dynamism of cosmic boundaries. The Big Rip hypothesis envisions a future in which the acceleration of expansion grows unchecked, eventually overcoming all gravitational, electromagnetic, and nuclear forces. Galaxies, stars, planets, and even atoms could be torn apart, leaving existence fragmented and dissipated. Boundaries once demarcated by matter and structure dissolve as expansion stretches space itself to infinity. In this vision, the edge of reality is not a wall or horizon, but a progressive unbinding, a slow erasure of the familiar cosmos into a void of increasing emptiness. The heat death of the universe presents a different, subtler finale. Here, boundaries dissolve into eternal silence, not through violent expansion, but through entropy, the gradual equalization of energy across the cosmos. Stars burn out, matter decays, and the universe cools toward a uniform, featureless state. Boundaries of structure, activity, and distinction fade, leaving a cosmos where time flows but nothing meaningful occurs, where existence is an unbroken expanse of thermodynamic equilibrium. Even in this ultimate quiet, the concept of beyond becomes philosophical. There is no edge, yet the universe approaches a state where distinction, activity, and structure vanish, challenging notions of purpose and finality. The Big Crunch, a mirror opposite of the expansionary scenarios, suggests that all matter and energy may one day collapse back into a singular state. Boundaries, in this case, are inverted. The cosmos that once stretched outward recedes into itself, converging toward a dense, primordial point. Space contracts, time may fold, and the universe may return to a condition reminiscent of its origin. In cyclic models, this collapse may itself spark a new expansion, rendering the boundary a transitional phase rather than an ultimate end. Here, edges are not termini, but thresholds of transformation, bridging past and future, contraction and creation. These mainstream theories converge on a profound philosophical implication. Boundaries of existence are rarely fixed or absolute. They are dynamic, emergent, and context-dependent, shaped by forces, laws, and parameters that extend across scales from the subatomic to the cosmological. Whether through the branching proliferation of eternal inflation, the rhythmic cycles of existence, the hidden dimensions of string theory, or the expansive possibilities of the multiverse, the universe resists simple delineation. Edges are often horizons, thresholds, and transitions rather than walls, demanding that science embrace both observation and abstraction. Each theory also illuminates the interplay between time and space. In eternal inflation, temporal horizons may stretch infinitely, producing new universes at every instant. Cyclic cosmology emphasizes the rhythmic recurrence of temporal boundaries. The Big Rip, Heat Death, and Big Crunch each impose ultimate temporal outcomes, defining the limits of duration rather than location. Even dimensional boundaries in string theory suggest that time and space are intertwined with hidden axes, revealing that the edges of reality are as much a function of structure as of epoch. Moreover, the human imagination mirrors these cosmic boundaries. From Einstein's field equations to contemporary simulations of multiverses, science itself is a bridge across edges, connecting the observable with the speculative, the tangible with the abstract. Boundaries in the cosmos provoke reflection on mortality, on the limits of knowledge, and on the ephemeral nature of all that is. The universe is not merely a physical entity, is a mirror of cognition, an arena where perception, mathematics, and philosophy intersect. Every horizon we probe, every edge we theorize, illuminates both the cosmos and the mind that seeks to understand it. Even in contemplating the extreme ends of expansion or collapse, there is an underlying symmetry and elegance. The processes that generate new universes in eternal inflation echo the cyclical patterns of existence. The contraction toward the big crunch mirrors the expansion into a big rip. Heat-death, in its uniformity, is a counterpoint to the energetic turbulence of creation. Boundaries emerge not as abrupt limits, but as natural transitions in a continuum of possibilities. Science, in mapping these frontiers, reveals a cosmos in which edges are meaningful not as obstructions, but as indicators of principle, markers of transformation, and invitations to wonder. The interplay between observation and theory is central to understanding these boundaries. Telescopic surveys, cosmic microwave background measurements, gravitational wave detection, and particle physics experiments extend the empirical edge, while theoretical models push into domains beyond current verification. Boundaries here are layered: empirical, mathematical, conceptual. They define the reach of evidence, the extent of prediction, and the horizon of speculation. Mainstream cosmology thus presents a multidimensional frontier, where what is seen, what is calculated, and what is imagined converge, and where every conclusion carries the shadow of the unknown beyond. Ultimately, the mainstream theories of cosmology portray a universe both richly structured and profoundly open. Boundaries exist, but they are fluid, contingent, and often imperceptible. Inflation, cyclic models, string theory, multiverse, speculation, and the ultimate fates of expansion or collapse each reveal different aspects of this structure. Science approaches these edges cautiously, combining observation with abstraction, measurement with imagination. In doing so, it not only maps the cosmos, but also illuminates the nature of reality itself, a tapestry woven from matter, energy, space, and time, yet extending into horizons beyond comprehension, defined as much by principle as by substance. In facing these cosmic theories, humanity confronts the duality of existence, the finite and the infinite, the known and the unknowable, the observed and the speculative. Boundaries are invitations rather than walls, thresholds rather than endpoints, reminding us that every discovery reveals a new horizon, and every horizon hints at deeper mysteries. Mainstream science, in its most elegant formulations, is a meditation on continuity, on transformation, and on the profound subtlety of a universe without a final boundary, a cosmos whose edges are both real and conceptual, tangible and elusive, illuminated by knowledge yet shadowed by the infinite dot at the outermost reaches of cosmological thought. Science flirts with the boundaries of speculation, where the line between physics and philosophy begins to blur. One provocative idea is the simulation hypothesis, which proposes that what we perceive as reality may itself be the output of a computational process, bounded not by matter or energy, but by information and processing limits. In this framework, the edges of existence are determined not by cosmic horizons or singularities, but by the architecture of a computation. The universe, then, is a vast and intricate algorithm, a self-consistent illusion in which galaxies, stars, and consciousness emerge as emergent phenomena. Boundaries are simultaneously real and artificial, imposed by the underlying system rather than intrinsic to reality itself. To contemplate a simulation is to confront the possibility that the very notion of beyond is contingent, defined not by physics but by the constraints of code, memory, and rules beyond perception. Quantum mechanics introduces another profound frontier with the notion of parallel realities. Every quantum decision, every probabilistic outcome, may generate a branching universe, a discrete path in an endless multiverse of possibility. In this many worlds interpretation, Boundaries are not walls, but proliferating trees of consequence. Each observation, each choice, each interaction births a new trajectory. A universe slightly different, diverging in detail yet coherent in structure. Existence is thus a ceaselessly branching tapestry, where edges are illusions, and every horizon is but a node in a sprawling network of realities. The cosmos, in this view, is infinite not merely in space or time, but in the richness of possibilities that unfold continuously, beyond any human capacity to traverse or even perceive. White holes, the hypothetical mirror images of black holes, offer another speculative perspective on boundaries. While black holes consume matter and energy, trapping even light, white holes are theorized to expel everything, an eruption of space-time that could act as an exit from regions where known physics collapses. Though unobserved, white holes arise naturally in certain solutions to Einstein's equations and in models of quantum gravity. They suggest that singularities may not be ultimate endpoints, but transitional zones, portals through which information and matter could re-emerge. In such a scenario, the boundary of existence is not a final wall, but a conduit, a region where the familiar rules of physics dissolve only to reconfigure in unexpected ways. Space, time, and matter could be recycled, expelled into domains unreachable by direct observation, hinting at a cosmos where the concept of beyond is both literal and profoundly elusive. Brain cosmology expands this speculation into higher dimensions. According to these models, our universe may be a three-dimensional brain floating in a higher dimensional space, where other brains could exist in parallel. Collisions, interactions, or gravitational effects between brains could generate phenomena observable in our own universe, perhaps even triggering events like the Big Bang. Boundaries, in this framework, are multidimensional. The edge of our brain is not a limit in three-dimensional space, but a surface within a far richer topology. The universe is embedded within something larger, unseen, and fundamentally inaccessible to ordinary perception, suggesting that what we consider the entirety of existence is only a fraction of a more intricate and multidimensional reality. Speculative physics also questions whether the concept of beyond has intrinsic meaning. Thinkers like Sabine Hossenfelder challenged the assumption that reality must extend beyond observable limits in any physically meaningful way. Perhaps some questions about the true edge of the universe, the nature of space-time before the Big Bang, or the ultimate composition of reality are fundamentally undecidable. Boundaries, then, are not merely scientific problems, but philosophical reflections. The universe may present apparent limits that cannot be transcended, and beyond may be an abstraction imposed by human curiosity rather than a feature of reality itself. In this sense, speculative physics invites humility, reminding us that the cosmos might be bounded not by walls, but by the constraints of consistency, observation, and principle. Time itself becomes a frontier when pre-Big Bang models are considered. Hawking's no-boundary proposal envisions the universe as finite but unbounded, a temporal surface where the familiar concept of before ceases to apply. The universe emerges smoothly from a quantum regime without a singular origin, erasing the traditional edge of causality. Boundaries, in this context, are not physical barriers, but transitions in the fabric of time itself. Time before time, space before space, are not accessible through conventional measurement. They exist as mathematical and conceptual constructs, inviting contemplation of a reality in which beginning and end are inseparable from the laws that generate them. Even consciousness, enters these speculative frontiers as a potential boundary of existence. Some theorists propose that awareness itself may play a role in defining reality, or that the emergence of conscious observation imposes constraints on the manifestation of physical phenomena. If perception is a boundary, if reality crystallizes through interaction with conscious observers, then existence and its edges are intimately tied to cognition. Boundaries are no longer solely external. They are relational, contingent upon the interplay between observer and universe. Consciousness may constitute a frontier as fundamental as black holes, the Planck scale, or the edges of spacetime, a threshold where the universe intersects with awareness, and where physics and phenomenology converge. Taken together, these speculative and fringe ideas challenge the very framework of cosmology. Boundaries become mutable, multidimensional, relational, and sometimes illusory. The simulation hypothesis imposes computational edges. Parallel realities multiply horizons indefinitely. White holes and brain cosmology introduce hidden portals. Pre-Big Bang models dissolve temporal limits. Consciousness suggests subjective thresholds that may shape reality itself. The cosmos is both stranger and more intricate than classical intuition permits, an interplay of law, chance, and possibility that defies simple characterization. Speculative theories also emphasize the continuity between mainstream physics and the unknown. Concepts like eternal inflation, dark energy, and quantum fields find echoes in fringe models. Branching universes, hidden dimensions, and pre-Big Bang states extend the insights of empirical science into uncharted territory. Boundaries in this context are emergent, reflecting the interplay of observable phenomena and the underlying principles that govern them. Science, even when speculative, maintains rigor by anchoring these ideas in mathematics, consistency, and compatibility with known laws. Yet the edges it confronts are often as much conceptual as empirical. Moreover, these ideas illuminate the profound philosophical tension inherent in exploring existence. Speculative models confront the human desire for total comprehension, the longing to map the cosmos in full. Yet in doing so, they reveal that ultimate boundaries may be unreachable or may exist only in relation to the observer, the laws, or the conceptual framework through which observation is conducted. The universe, in this view, is a dialogue between known and unknown, a spectrum of reality where the edges are simultaneously revealed and concealed, and where each attempt to extend understanding creates new horizons beyond reach. Even the act of contemplation becomes a form of exploration. As theoretical physics pushes against the frontiers of what can be known, the mind itself becomes a probe into the unknown. Mathematical models, simulations, and philosophical reasoning function as tools to navigate edges that cannot be traversed empirically. Boundaries in speculative cosmology are thus as much cognitive as physical, as much reflective as objective, reminding us that existence is both a phenomenon to observe and a mystery to inhabit. Ultimately, the speculative edge of cosmology reveals a universe that is profoundly intricate, surprising, and fluid. Boundaries exist in multiple forms: quantum, dimensional, temporal, and conscious, and each challenges the conventional notion of an edge as a fixed or absolute limit. The cosmos is vast not only in scale but in possibility, and each speculative framework illuminates different aspects of its structure and potential. To engage with these ideas is to confront the ultimate tension between knowledge and mystery, between the measurable and the ineffable, between the observed universe and the boundless realms of what might lie beyond. In this frontier, speculation is not mere fantasy, is a method, a disciplined extension of scientific reasoning into domains that current observation cannot penetrate. By contemplating simulations, parallel realities, white holes, brains, pre-Big Bang states, and consciousness, humanity probes the limits of understanding while respecting the constraints imposed by mathematics, physics, and logic. Boundaries are reframed as thresholds rather than walls, as invitations to inquiry rather than final answers. The edges of existence become reflective surfaces, revealing both the cosmos and the nature of inquiry itself, showing that to explore beyond is as much a journey of the mind as of the universe. Thus, in speculative and fringe cosmology, existence is at once more bounded and more expansive than perception alone allows. Horizons proliferate, dimensions multiply, time bends, and consciousness may define the very limits of reality. Boundaries are provisional, relational, and often paradoxical, yet they structure our understanding and ignite our curiosity. Science, in this luminous interplay of speculation and rigor, guides us toward questions that may never be fully answered, inviting us to dwell at the edge of comprehension and to marvel at the profound mystery of a universe whose ultimate frontiers are at once seen, unseen, and perhaps unknowable. Speculation in cosmology also invites the contemplation of hidden mechanisms, subtle structures that might exist beyond any possibility of direct observation. Consider, for instance, the concept of vacuum energy, the quantum fluctuations that permeate the very fabric of space. Even in the emptiest regions of the cosmos, a restless sea of virtual particles pops in and out of existence, suggesting that nothingness may itself be a complex, dynamic phenomenon. If the universe is a simulation, or if multiple universes exist in parallel, these fluctuations may serve as the scaffolding upon which reality is constructed, a boundary that is at once infinitesimal and foundational, a threshold that defines the emergence of matter, energy, and the rules of physics themselves. In contemplating these microcosmic limits, the mind is drawn outward, recognizing that the smallest scales may shape the largest, and that boundaries are fractal, present in both the infinite and the infinitesimal. Some speculative frameworks suggest that these boundaries are not static but probabilistic. Quantum cosmology posits that the universe itself may exist in a superposition of states, with multiple configurations coexisting until a form of cosmic observation collapses possibilities into a single emergent reality. In this view, edges are not rigid demarcations, but zones of potential, regions where reality is neither fully defined nor fully absent. Boundaries become events rather than places, moments in which the universe crystallizes from the fog of probability. Every transition, every bifurcation of possible histories, creates a new frontier, an ephemeral horizon whose contours are shaped by the interplay of chance, law, and observation. The role of consciousness as a potential frontier also deepens in this context. If observation participates in the manifestation of reality, then awareness itself might delineate boundaries in subtle ways. The act of perception could define what is real, separating existence from potentiality. In such a framework, human cognition is not merely a passive observer of cosmic phenomena, but an active participant in the unfolding of reality. Boundaries are relational. They exist in the interface between the observer and the observed, shaped by measurement, interpretation, and the emergence of experience. This notion challenges classical ideas of objective edges, suggesting that the final frontiers of existence may be entangled with the very processes of consciousness that contemplate them. Brain cosmology. 2. hints at unexpected forms of connectivity between what appear to be separate universes. Collisions, near approaches, or gravitational interactions between brains could generate phenomena visible within our own universe. From the creation of galaxies to the triggering of cosmic inflation itself. In this sense, boundaries are permeable, interactions that defy our intuition of isolation. The universe may be a vast ocean of brains, with subtle bridges connecting distant realms. Existence is thus both bounded and extended, defined by the brain we inhabit, yet influenced by entities and forces beyond immediate perception. Horizons become relational, contingent on context, and subject to the hidden architecture of higher dimensions. Speculative physics also encourages reflection on the nature of causality itself. Pre-Big Bang models, including Hawking's no-boundary proposal and loop quantum cosmology, suggest that the familiar flow of time may be emergent rather than fundamental. Boundaries in these models are not merely physical, they are temporal, conceptual, and topological. The universe may exist in a state where before and after lose their conventional meaning, where beginning and end are features of a mathematical manifold rather than observable events. Such perspectives dissolve traditional notions of edges, replacing them with regions of continuity and transformation, where existence itself emerges as a self-consistent structure without clear demarcations. The philosophical weight of these ideas is profound. Speculative cosmology confronts the human desire to map the universe in full, yet reveals that ultimate boundaries may be unattainable. Every attempt to define the edge of reality generates new questions, new horizons, and new dimensions of uncertainty. The universe becomes a dialogue between known phenomena and the limits of speculation, where the act of inquiry itself defines the frontier. Boundaries are thus simultaneously intellectual and physical, epistemological and ontological, guiding exploration while reminding us of the limits of comprehension. Even mathematical structures, which underpin many speculative theories, suggest boundaries that are conditional rather than absolute. Topological features, symmetry principles, and higher dimensional manifolds impose constraints on what is possible, shaping the behavior of matter and energy while leaving room for variation and creativity. In this sense, the universe's edges are not simple walls, but conditional surfaces, thresholds shaped by the interplay of law, chance, and geometry. Science navigates these surfaces with rigor, yet the inherent uncertainty of extreme scales ensures that the frontier remains elusive, inviting continuous contemplation and imagination. Speculation also illuminates the poetic dimension of cosmic inquiry, the possibility of parallel realities, brain interactions, and consciousness-driven boundaries transforms the universe into a layered narrative in which every horizon, edge, and transition carries meaning. Boundaries are simultaneously literal and metaphorical, reflecting physical constraints while serving as symbols of human curiosity. The cosmos becomes a canvas upon which the mind projects both observation and wonder, a structure that is empirical, theoretical, and reflective at once. Ultimately, speculative cosmology reveals a universe whose edges are not fixed, but dynamic, emergent, and multifaceted. Boundaries exist across scales, from quantum fluctuations to multidimensional brains, across phenomena, from gravitational singularities to conscious perception, and across contexts, from empirical measurement to theoretical extrapolation. They are simultaneously physical, mathematical, temporal, and conceptual, forming a mosaic of frontiers that defines the limits of what is known, what is possible, and what remains unknowable in the quiet darkness above Earth. the James Webb Space Telescope unfolds its golden mirrors, a mechanical eye aimed toward the furthest reaches of time. Every photon it gathers carries a story from the dawn of the cosmos, from the first stars and galaxies that ignited when the universe was barely a whisper of its present self. In these ancient lights, humanity seeks to glimpse the contours of the early universe, to understand the processes that shaped existence and to push against the apparent horizon of all that is observable. The telescope's instruments, cooled to near absolute zero, allow us to peer past clouds of cosmic dust and unravel the history written in infrared wavelengths, revealing a cosmos that is both familiar and profoundly alien. Each image, each spectral line, is a whisper from the edge of time, a subtle nudge toward understanding what lies beyond the boundary of perception. Meanwhile, deep beneath the surface of our planet, particle accelerators hum with immense energy, smashing protons together at near light speeds to recreate conditions that existed fractions of a second after the Big Bang. These collisions produce showers of exotic particles, fleeting glimpses of the quantum architecture of reality. By observing the behavior of the Higgs boson, probing the symmetry of matter and antimatter, and exploring the properties of fundamental forces, scientists are constructing a map of the microscopic scaffolding that underpins the universe. The boundaries of existence in this domain are measured not by distance, but by scale, by the limits of energy, resolution, and human ingenuity. Each discovery brings clarity and mystery in equal measure. A particle identified today may illuminate a new horizon tomorrow, revealing that even at the smallest scales, the edges of reality are fractal and endlessly intricate. Advances in quantum gravity are pushing further into these extremes. Loop quantum gravity proposes that space-time itself is discrete, composed of a network of quantized loops, suggesting that the familiar continuum of space and time is an emergent illusion. String theory, with its landscapes of higher dimensions and vibrating filaments, offers another route toward unifying the laws that govern the very large and the infinitesimally small. Researchers simulate these models, testing their consistency and exploring their implications, attempting to reconcile the apparent smoothness of relativity with the discrete chaos of quantum mechanics. In doing so, they confront boundaries of comprehension, mathematical structures that hint at realms of reality inaccessible to direct observation, and at universes nested within dimensions we can barely imagine. The edge of existence becomes both a frontier of calculation and a conceptual horizon, a space where thought itself becomes an instrument of exploration. Efforts to detect dark matter extend this pursuit into the unseen. Invisible yet influential, dark matter sculpts galaxies and clusters, forming the hidden scaffolding of the cosmos. Deep underground, shielded from cosmic rays and terrestrial noise, detectors wait for the faintest interactions particles that may signal the presence of this mysterious substance. In orbit and on the ground, instruments scan for anomalous cosmic rays and gravitational effects, piecing together an indirect portrait of what cannot be seen. Here, boundaries are subtle, not edges in space,